Hello friends, welcome to Risingpearl.com. Today we are talking about series 4 where we are learning applications of trigonometry. This is webisode number 2, and friends, today we are going to take a look at right triangles and some very important things about right triangles. So now friends, very briefly, for series 3, the earlier series, we talked about the foundation of trigonometry because we are learning trigonometry for the first time in this grade, and everything, the ABCs of trigonometry, we saw that in series 3. So in the last webisode, that is the first webisode of this series, I have provided all the links to series 3. If you have not seen series 3, I strongly recommend you take a look at it before you start with series 4. Now that said, let's jump right into it. Now here I have drawn a person, let us just say it is me. I am actually looking at a beautiful, gorgeous tower. This is just a big structure. It could be tower, building, anything, right? And I'm standing on the ground, so this is the ground. And now my head is tilted up and I'm looking upwards. Now this line, there is no actual straight line, but this imaginary line, that is why it is shown in dotted lines. So this line is called line of sight. That is the line between my eyesight. So let's say my eyes are somewhere over here, right? I am actually looking up, and this line from my eyes to the top of the object I'm looking at, this is called line of sight, right? Sight as in sight, sight, looking, seeing, vision. So it's line of sight. Straight line from my eye to the object I am looking at. Now also, if you can imagine a straight line which is at my eye level again, which is parallel to the ground. So a straight line at my eye level which is parallel to the ground, so which is shown by this dotted line. This line is called horizontal. So this line is called horizontal. Now the angle which is formed here, this angle which is formed between the horizontal and line of sight, this angle has a name. So this angle is called angle of elevation. I'm writing it in short. This is angle of elevation. That means whenever you are looking up in relation to the horizontal line, you are looking up, it is called angle of elevation. Here this is basically the angle. This is, if you were to write it like completely, this will be angle of elevation, right? Now imagine we can always think about a perpendicular line which is coming right from the top of the tower, right through the middle of the tower to the bottom of the tower, right? So if you imagine it this way, then we can clearly see a right triangle which is formed. So between my line of sight, right, and the height of the tower and the horizontal line, if I can join them by solid lines, then I have a triangle, and I can name this anything. So it is, let us just name it A, B, and C, right? So this angle is 90 degrees. So this is a right triangle. The reason I wanted to explain this to you in good amount of detail, friends, is that because most of the applications of trigonometry will really revolve around this fundamental concept that your line of sight, your horizontal line, and the perpendicular which is dropped from the top of the tower to the horizontal. So this gives a perspective of, so if you think about AB is almost the height of the tower, right? So we have a triangle ABC which is a right angle triangle. So, and we also have an angle of elevation which is an acute angle. So then we can actually think about this in terms of trigonometric ratios, because we have a right angle triangle, we have an angle of elevation, and then we can actually, in most cases, we can measure either the height of the tower or how far we are away from the base of the tower, right? So, and you will see this in much more detail as this series goes on. And one just quick point to make is, so this length AB is not exactly the height of the tower in the strict sense, because the height of the tower will be AB plus this little dotted length, which is basically from my eyesight to the ground, right? But this is a very important concept to understand. So similarly, now think that you are or I am at the top of a building. It looks like I'm kind of hanging by myself. Just imagine that this is some sort of a building, right? So this is a building on which I am standing. So maybe I'm on the 10th floor. Now here I am actually looking down. This time, instead of looking up, I'm actually looking down. I'm looking down at a flower pot, right? So then what happens is, so at my eyesight I can draw again a parallel line at my eyesight parallel to the ground. So this is the ground in this case again, right? So this is the ground level or the ground. I can draw a parallel line parallel to the ground at my eyesight level. So this then becomes the horizontal or horizontal line, right? So this line is horizontal, and now this is my line of sight. So this line is my line of sight, this one, because from my eyesight to the object, the straight line from my eyesight to the object I'm looking at is my line of sight, right? So this is my line of sight. Now, so this angle which is formed between the horizontal and my line of sight, we saw we have angle of elevation. But when I am actually looking down and my angle which is formed between the horizontal and line of sight, if it is I'm looking down, then it will be called, instead of calling it angle of elevation, this angle we will call it angle of depression. Angle of depression. And just simply, if you are looking up to something, it is basically elevated, meaning upward. And if you're looking down on something, so D for down, D for depression. So again, so it's important, both angle of elevation and angle of depression are same in the sense that they are the angle formed between horizontal line and line of sight. If you're looking up, head is tilted up, then it is elevation. If you're looking down, your head is tilted down, it is depression, angle of depression. So similarly, friends, here, let's say there is a double-decker bus which is going close by. So I can look at the bus, the top of the bus, right? Then this is my line of sight. So in this case, so here, this is my line of sight when I'm looking down at the bus, the top of the bus, right? And then this angle, let us just mark it a little differently. So this angle is the angle of depression when I'm looking at the bus, right? Because at from my eyesight, the straight line, this is line of sight, and this is the horizontal. So again here, friends, we can kind of imagine that I can drop a perpendicular right through the top of the bus at the bottom, hitting the ground, and similarly here from the top of the flower hitting the bottom or hitting the ground. And then we can imagine we can construct right triangles, right? So here we have this as a right triangle. So in the first case, when I'm looking down on the flower, this is my right triangle. Let's name it. Let's say I'm at the point A. This is A, and we call this B and C. So this is, there are two triangles. One is triangle ABC. ABC. Here this angle B is right angle. Why? Because this is a building, right? So building is 90 degrees in relation to the ground. So this is 90 degrees. This is 90 degrees, and these two are parallel lines. So this is 90 degrees. Similarly, here this angle is 90 degrees. Let us name this triangle maybe A. Let's call this PQ. PQ. So for APQ, so there are two different triangles because there are two different objects we are looking at. So again, it is important, friends, that how we can actually think about right triangles, and then you will see we can really apply using the angle of elevation and angle of depression and our knowledge of trigonometric ratios. We can really start to find out some of these distances. That is, how far from the building is the plant, or how far from the building is the bus, or how high am I standing up, right? And you will see more and more these questions as we move forward into this series. Now, so one other thing that I wanted to just highlight, so here for angle of elevation is basically, so we have the horizontal, let's call it H, and this is our line of sight, we call it L, and this one, and this is our angle of elevation, right? So similarly, when we have a angle of depression, we are standing at the top and we are looking down, right? So in that case, this is the angle of, actually not this, so let us just show you this one. Here, this is the angle of depression, not this, because if we are standing here and this is the horizontal, right? So and this is a line of sight, so this would be the L. In both cases, let us just call this line of sight, so it will be just easier. So this is a line of sight, and in this case, this is the line of sight. It is very important to understand that the line of sight is basically the straight line from your eyesight to the object, right? If you're looking at the top of a building or top of a bus or top of the flower plant, so it is from the eyesight to the object. And angle of elevation, in this case, this is the angle of elevation, angle of elevation, and in this case, this angle is the angle of depression, angle of depression. So what is very important to understand, friends, is that if you know this angle, that means you know this angle. And you can say, why is that? So let us say this angle is this angle, because recall that this line is parallel to this line, right? These two lines are parallel because this is the ground and this is a line which is parallel to the ground at my eyesight level. So if I have two parallel lines and if I have a transversal, then these are alternate interior angles. So that means if I am given the angle of depression, then in this right triangle, and both are right triangles here. So here this is 90 degrees, here this is 90 degrees. So in both right triangles, I have one angle of elevation which may be given to me. I have my line of sight and I have the horizontal, or how far away one of the lengths, if it is given. I can really calculate the other length, meaning that there are three sides of a triangle, right? So in this case, there are three sides. In this case, there are three sides. So if the angle of elevation or angle of depression is given, and if one of the sides is given, we can really use the trigonometric ratios to find out the other sides. And this is what we are going to see. So most of the questions that you will see are really related to, let me just write it here, are related to height and distances. Height and distances. So most of the applications of trigonometry will be related to height and distances using the angle of elevation or angle of depression. Now friends, before we actually look into the questions, one final reminder is that we have talked about this table many times before. It is absolutely important for you to remember this table. This is the table of trigonometric ratios of some very important angles, sometimes also called as standard angles. That is, these are the 6 trigonometric ratios: sine, cos, tan, cosec, sec, and cot. For these angles, for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Because when we look at the questions when we're going to solve these problems, we will automatically assume that you know these values. So that's it, friends. We are going to, in the next episode, take a look at some questions of what kind of questions we can expect and how do we solve questions using our knowledge of trigonometry.